Hi everyone. I have to start over because I forgot to press the go live button. So we're going to start that one more time. My sincere apologies. You get to hear that again. Oh, and we get another classroom that's just signed on. Sorry. We'll go through this really quickly. Hi everyone, welcome. My name's Todd Bohannon. I'm an educator with REEF, the Environmental Education Foundation. I work on this project, the Grouper Moon Project, and have for the past 13 years, writing curriculum and working with students throughout the Caribbean, but specifically mostly classrooms here in the Cayman Islands, on Grand, on the Brac, and here on Little. Now today we are streaming to you live from Little Cayman on the porch of the Grouper Moon headquarters for 2024, which is a bustling house that's been rented for the last week and next week, housing a bunch of researchers who are collecting data out on the research site, out on the spawning aggregation here on the west side of Little Cayman. Today, I would like to introduce you guys to some of the people that make this project happen, who are just critical for this unique project. First, I'm going to introduce you guys to a couple of researchers from the Department of the Environment. So right here to my left is Dr. Croy McCoy, winner of the International Scuba Diving Hall of Fame from 2019, CIG lead on the project, as well as Paul Chin, who is a research officer with DOE and works on this project as well as multiple other projects. Croy.
Yes, sir.
Can you tell us a little bit about how you got started with this project?
Well, I'll start a little further back.
That's fine, yeah.
My history with the ocean, my second home, I call it. Started diving at a young age.
Yeah.
9, 10 years old.
Right.
And then I attended Spot Bay Primary in the Brac.
Shout out to Spot Bay.
Cayman Brac High School.
Yeah.
And went off to university after that.
Where?
Studied marine biology. It was just the curiosity of the ocean is what drove me to where I'm at right now.
And was that part of your family? Like, did your family encourage that, or was that something unique to you? Were you?
Well, from my dad's side, the diving aspect of it, 'cause that's all I really did.
Right.
And I mean,
okay.
That sort of like this is one job I've had my whole life is marine science, ocean sciences, and I started with a department with groupers also in 1995. The project was sort of running before that but the aggregations in the whole region was pretty much fished out beyond, any means of numbers and such because of fishing pressure.
Fished to the point where they're no longer really viable aggregations.
Yeah, the fishery had collapsed, and
Okay.
I started working there with that, and then that emerged into when they rediscovered the Nassau groupers over in the western Little Cayman in 2003, and that's when the project really kicked in, and
How did you guys find it on Little Cayman? What was the event that happened that you guys realized that this was here?
It was two guys from the Brac that found it, and I can't thank them enough for not only.
There we go. So, icon of the Caribbean. So in what was it? Was it 2007 that it was found, the aggregation?
2003.
2003. And then what happened after that?
Well, once it was discovered, it was fished down to low numbers again.
And low numbers meaning what? About 1,200?
We estimate it started around 5,000 fish.
Okay.
It was fished down.
Hey everyone. So one of the exciting things about working on a field research project is that things can and do go wrong. So our internet is being a little bit spotty today. We appreciate you being patient. If we cut out again, just hold tight. It should only take a couple of seconds. There we go. Okay, so continue with your story. We were talking about how it was fished down from 5,000 to about 1,200.
1,000 fish, 1,200 fish, and the Cayman government then put a moratorium on them, and we started. That's when the affiliation with Reef started. We had to do the biology and ecology and the science to back policy.
So what policy was it that you were trying to find this?
We needed to develop a fisheries management plan.
Okay.
For this particular species, because it was such it's an iconic species of the region up until in the 80s when regionally they were fish.
Right.
But they're always being fished at an unsustainable level, and here was this new discovery that was a treasure and an opportunity to do it right.
Right.
We always did it wrong in the past. I mean, all the countries in the region just fish their Nassau groupers to collapsible.
Exactly.
State.
So essentially what you're saying is when there's a population of Nassau, a healthy population, when it gets down to a certain point, it's no longer, there aren't enough to replenish those that have been taken away? Is that what you're saying?
Yeah.
Okay.
And these are mass spawners, so even though some of the females can produce millions of eggs, only 1% or maybe one or none for that year will survive to adult and reproduce again. So it's very critical that you retain a viable population of these fish to ensure going forward that you have a reproductive population.
Right.
Always contributing to the population, sort of like how human beings, have kids and they grow up to replace us. That's basically.
So in order to put regulations in place, you guys had to do some research and prove a few things. What was it that you were doing?
Well, we did many things, but one of the myths that we had to disprove is the fact that they came from other islands.
So fishers thought that we were getting that were probably coming from maybe Cuba and other places.
Yeah, and Picklebank and just other countries and
right.
stuff. And so we set up an acoustic area around the island, and we acoustically put tags in each fish where we would catch them and surgically insert these. We call them pingers because they emit a code, and
So you put a little
incision, insert it into the gut cavity, and suture it back up or stitch them back up,
right,
and then release them.
So if you guys watched the Changing Seas Grouper Moon documentary, you will have seen that, exactly what he's talking about in that video. And if you haven't watched it yet, I highly recommend as a class you watch the Changing Seas documentary, and you can actually see the researchers catching the Nassau back then and putting the acoustic tags inside of them and then re-releasing them. Now, what did that help you do?
Well, it told us, well, we did the hormone levels and stuff. They were male or female, so we knew where they lived. Because Nassau grouper, wherever they settle out as juveniles, usually spend their entire lives there. They're solitary animals except for that one time of the year that they all, aggregate
right.
to.
So at normal times, if you were to see a Nassau any other time of the year, you would see it in its one spot where it lives, its home reef, which is fairly territorial. And it doesn't hang out with others. In fact, if another Nassau would come into its territory, what would happen?
Yeah, that's a fight.
A fight would happen, exactly.
Yeah, they defend their territory mainly for food resources and stuff.
Okay.
And it also told us the behavior and how they operate in this mechanism that drives the aggregation. Like we know the males that we tag will leave the aggregation and go and sort of I guess you cruising looking for chicks.
Yeah, exactly. They're cruising around looking for other fish.
Yeah, it's the younger generation that don't know where to go when that cue kicks in to reproduce, and he'll go and just pick up 10, 20, and they call it's a migration of them.
A migration.
And you always hear people, fishermen, other people see these groups of Nassau groupers coming along the edge of the shelf.
Yeah.
And that's a male up front, sort of. Hey, this
hey guys,
is going to happen.
Right.
Let's go down to the west then.
Which is interesting. This is a question that's come up about a bunch with classrooms. It's how do the Nassau know what to do? And what you're saying is that the older Nassau literally teach the younger Nassau what to do and where to go.
Exactly.
That's amazing.
So that's was part of it, but we've done a lot of other work besides that too.
So you were able to prove, though, that those Nassau were all here, that they weren't coming from...
Exactly.
And you did that with the acoustic tags, and what else? Did you do DNA?
Yeah, we did some genetic work, but excuse me. One of the things with tagging the fish too is the we tag them on the aggregation itself. 30 fish on there because they're the ones that was.
And when you say tag, that means they're putting a little, it's called a spaghetti tag or a little Floyd tag. It's just a little piece of jewelry that hangs off the side of the fish. Doesn't actually hurt them, hangs off them, but it's bright enough that you can see it, right?
Yeah, that's the tag we do for tag and capture.
Oh.
The
You're talking about
tags we use.
Those are the ones that go inside the body cavity.
Cavity, yeah.
Okay.
But we also, do temporary tags on them for tag and recapture.
I see.
We also had to know how many was there.
Right.
And that's one method that's been around for a very long time, and we just use that along with other. We take video of the population and make poor undergrad and grad students sit there and count fish. There's various methods that we use, and we've gone into, as you know, using facial recognition of the fish now.
Right. So just to give you a little background on that, when the project started and the researchers were counting fish, they were using these, they would go out and tag a certain number of fish. And they didn't know how many fish were out there. They just knew how many tags they put out. And then they would go out and they would do counts of 50 fish at a time, over and over and over again. And of those 50 fish, how many of them had a tag? And that would give you a percentage of the entire population.
Yeah, you extrapolate that data. And,
right. Math, you guys, the math, right? So, but what Dr. McCoy is also saying is that now technology has really exploded on this project since we've begun. I mean, it's night and day from where we started, from the quality of the underwater cameras to the technology that we use to count them. And now we're using facial recognition technology to identify the fish. Can you explain how that works?
Well, each of us have a signature, how our faces look, and little patterns, a little scar here, I guess you could say.
A little wrinkle there.
Every Nassau grouper has a pattern on his coat, I guess you could call it.
Right.
And we take pictures and video of all of these animals that on an aggregation, and we run it through the computer software, and it picks out each animal repeatedly, and we know which fish is which.
So you're creating like a database of fish faces.
Yeah.
For each individual fish.
Exactly, and we can follow them with that throughout the whole span.
Right.
They come back each year.
So you could see one year, and the next year the computer software would identify them as the same fish. So you can see who's coming back over and over.
Yeah, and for the size classes, how big the fish is, originally we built an old Hi8 camera. That's how long ago that was.
Hi8 camera. For those of
like
you younger, well, actually all of you are younger on here. We used to use these things called video cassettes that would go into a camcorder, and that's what we used to record on. Things have changed since then.
And we put two lasers, underwater lasers, on either side, and the distance of 25 centimeters apart.
So that was the laser calipers that you would take out, right?
Yeah, and then we adjusted it till we got 25 centimeters here, and maybe 200 feet away, it should remain at 25 centimeters. So we would go along taking pictures of the fish, and if we knew that was 25 centimeters, then we could look at
you could figure out how long the actual fish is. So what Dr. McCoy is saying is, aside from identifying the different fish, they're also trying to figure out how big those fish are. Exactly. And in order to do that, they were using lasers that were on a bar, and those lasers were exactly parallel, 25 centimeters apart. And so they would shoot those towards one of the side of a Nassau and take a picture. There'd be a little camera on there to take a picture. And you would see where those two parallel lasers hit the fish, and then you could tell from that the exact length of the fish.
Yep.
And why is that important?
Because we needed to know when they recruit, not only to the aggregation site, but how healthy the population is in the larger individuals that are on the aggregation in itself. And because fish are not like humans, the older they get, the larger they get, the more eggs they produce, and the healthier eggs they produce, or the more
So the older the fish, even the more eggs and the better quality eggs.
better quality. Yeah,
Okay, and they can actually reproduce all the way until the end of their life.
exactly.
Incredible.
And
So,
Nassau groupers are long-lived species. They live. We did some of the first work back in the 80s here, and it was like 30 years old. So we know they live 30 plus.
Yeah.
And that's a long time.
That is
for
a
any
really
fish
long
to live.
time.
Yeah.
that's amazing. So it looks like we have a new.
Yeah, that
So
same
right
laser
here-
stuff we were talking about, we graduated into stereo video, and I'll let Paul explain that.
So this is Paul Chin right here, research officer, and he's got with. Why don't you just tell us a little bit about yourself first, and then you can talk about stereo video.
Sure, no problem.
How did you get started?
I am Paul. I'm a research officer with the Department of Environment. My beginnings is not as long as Croy here, but it's a little ways off, a little longer than you guys have been around. I graduated from high school in 2002, but prior to that, I attended Red Bay Primary.
There we go. Sorry about that, guys. We are
Sorry about
back.
Yeah, so as I was saying, I attended John Gray High School, so shout out to them as well.
Apologies again, you guys. We're back.
Yep.
All right. So it was by accident.
Yeah, so by complete accident, actually. I was actually in school to be an engineer, a mechanical engineer, actually, in fact. And I was doing some work with the World Wildlife Federation, where while I was doing that work, I encountered a pregnant seahorse. And after doing some research, I found out that pregnant seahorse just happened to be male.
Great.
So it kind of that's the opposite, right, of what
Yeah.
we're used to. So that just kind of turned my world upside down as well.
Kind of blew your mind.
Yeah, exactly. So
Yeah.
I figured that that's probably where that triggered a passion for me, and I've been doing it ever since. So I've been doing it for the Department of Environment 15 years officially, but unofficially a little over 20 years. And ever since I started officially, I've been under the wing of this young gentleman here next to me. So I'm very thankful for the experience and thankful for the knowledge that he's passed on to me as well.
Paul, how did you get from John Gray to here? Like, what did that path look like?
So that path was, I was actually quite privileged. After graduating from high school, I was awarded a scholarship to attend an international school in Hong Kong. So I spent 2 years in there where I got an international baccalaureate.
Wow.
And then after, that's actually where I found my passion, is I actually was doing that volunteer work in Hong Kong. And that's when I got my diving certification. Not the most ideal place to get your diving certification.
Why is that?
Because, like I said, when you're growing up in the Cayman Islands, sometimes you're not really quite aware of what you're blessed with, some of the
Right.
beautiful blue waters that
You
we
tend to
have here.
take for granted what you see every day.
Exactly, because it's what we've grown up with, is what we know. So after not having that for 2 years, you kind of miss it, and then you realize that, okay, I'm really, really blessed with what I have at home. And then after taking on my passion and realizing that that's the route I wanted to take, I've been doing it ever since then.
That's amazing.
And then I took my tertiary education to the UK, where I attended the University of Essex, and I achieved a bachelor's and a master's in marine biology.
Wonderful.
Yeah.
That's a great story.
Yeah.
Now, you have a new piece of equipment that
Right.
we've been talking about.
So we've advanced a little bit more technologically from those VHS and high tapes that we used to use, and we've come up with what this is now. Is what it is just what we call stereo video. This here is two handles, and it collapses right down the middle here. It's got sort of like a spindle, so it collapses and folds in half. Now on each end of this contraption here, we have two GoPros, and those GoPros
Oh, yeah,
are
hold it up
mounted.
just a little
There we
bit.
go. Can you guys see that?
And guys, I will take a picture of this today or a little video and I will post it on the blog so you can see it really clearly.
Right. So on each end of the stereo video, you have a GoPro, and these GoPros are slightly angled at a very small degree of angle, where it operates just like a human's face, like eyes.
Like your
so you
eyes.
have two eyes, which eventually come together to make one image. So with this being calibrated like it is, we are able to capture those images of those fishes, and because we already know the known size of the
Between
distance
the
between
cameras.
the cameras, we can actually measure the size of each fish.
That's incredible. Now, what is your specific job on the project, Paul? What does research officer mean?
Well, research officer, like Croy, I help out and I assist in any way I can with the reef team with the science-based stuff. So we go down, we capture the fish faces, we do the fish counts, and anything that we can help with in terms of the scientific side of it, we try to do as much as we can to support the project.
Wonderful.
Yeah.
Thank you guys so much for
Sure.
being here.
I wanted to say a shout out to Arian, my son, who's on there. Also
Hi,
a diver.
Arian.
So,
Wonderful. Thanks for being here. All right. So thank you both for being here. I'm going to pull up another researcher that I'd like you guys to meet today. Just one second while we get ourselves. I'm going to introduce you guys to a reef researcher whose name is Allie Candelmo. Allie, hi.
Hi.
So can you tell us a little bit about what your role is here on the Grouper Moon Project?
My role is to help with the research, the field work, also just the logistics. I help get the food for the team here, and to place the food orders.
That's no small task on a tiny island in the middle of the Caribbean.
Track down the food orders. Coordinate, just unpacking, helping with data unload, and then the data analysis of the project and kind of planning of what we're going to do each year after that.
So you're really dealing with a lot of the logistics of the project.
Yes, but between me and some others, we
Sure.
kind of help get everything we need here, and then figure out how to get it out in the field, and then what to do with it after that.
Now, I mean, Allie, just like all of the other scientists on this project, are bustling around all day. I mean, it goes from the moment they wake up until the time they go to bed. Can you kind of walk us through what does the day look like for a scientist here on the research project? What do what are the things that you're doing?
Yeah, so we get up and kind of go right from the start, decide what time we're going out diving, who's going out, and making sure again we have all the equipment that we need to get it to the boat. So we bring out GoPros and the stereo videos, and sometimes like egg collection bags or nets, depending on the project at the time.
So like egg collection, explain what you're talking about. When do you go collect the eggs, and what scientific tool are you using to collect them with?
So in the evening, we go out and when they're spawning, we'll go and try to collect pair eggs from just individual rushes. So we'll go out as usually a pair and watch to see when the fish are going to spawn. Together, you kind of track the fish along, and then as you see a group that looks like they're getting, pretty active,
Ready to go.
We rush in there, and usually just with a Ziploc bag.
Ziploc baggie.
And that's been the most successful at not harming or killing any of the eggs. We also can use nets. Sometimes we use a big plankton net where we kind of swim through the water and collect the whole population's eggs. And then other times we've used these like really fine mesh butterfly nets that are pretty soft, but they still do damage the eggs a little bit, but you can get more eggs with those.
So they're pretty delicate, those eggs.
So the Ziploc bags are best. You just open it right under the eggs, and it tends to suck them in. If you can see the eggs, you hold the light up to the eggs,
Right.
and then you suck in a little, cluster of eggs, and we don't get not even a percentage of what each
So
fish is
what you're
spawning.
taking isn't actually having an impact on
No.
the population.
Each fish could spawn like 1 million eggs, and we're getting, if we're lucky, really get like 500 or.
And could a Nassau release as many as 1 million
The
eggs?
big females, sure, yeah.
Or even more?
They're releasing a lot, yeah.
Yeah. So I'm going to actually, since we're talking about it, I'm going to show you guys a couple of clips of spawning that's been happening for the last 3 nights here on the west end of Little Cayman. So hold on tight, and I'm going to share with you a couple of video clips. So you can see them going up there and releasing their gametes. Okay, I'm going to show you one more clip, and then I'm going to have Allie talk a little bit about what we just saw. Wow. Okay, Allie, a couple of things. Those Nassau didn't look like the Nassau that I normally see when I'm diving. What's going on there?
Yeah, so during this time of year, they change their colors. And the Nassau actually have 4 color patterns. So they have their kind of classic barred. They have a white belly where they sort of have that whiter belly like you're seeing there as in the spawning phase, but then they still have the bars on top. And then they turn into this really cool bicolored phase is what we call it. And that's their spawning coloration. And that's, when during the spawning period, you'll see a number of them start to get bicolored. But when they're all spawning at night, they're all in that color phase. And that's just saying, I'm ready to go. Here
so they're
I am.
communicating
Yes.
using color, and they can change their color similar to an octopus.
Right in front of your eyes. Yep. We've got videos of fish going from one bicolor phase to back to barred and white bellied, and then they have a darker phase as well.
And so when you're out there, does the coloration start to indicate to you when they're getting ready? Like, how do you guys know when they're going to start actually spawning?
Yeah, so as we're out in the field during the week, we'll actually kind of try to estimate a percentage, like this many were barred, this many were white belly, this many bicolored. And then as you start to see more and more bicolored, particularly in like the later afternoons, they're getting ready, and that evening they're probably going to spawn.
Now, so I've heard some people talk about hydrating, that the eggs get hydrated, and all of a sudden you'll see the fish out there one day and they look, kind of slim and trim, and then the next day you'll notice some that are really fat. What's happening there? Because that's what I've heard people are saying, that means they're getting ready,
yes.
that they're about to release.
So the eggs are ultimately filling with water. So they have, their ovaries are filled with the eggs.
Okay.
But they're not ready to spawn. They're not ready to be released, and they have to get filled with water, which then they'll be buoyant. When they release them, they release,
So buoyant means what?
So they'll float.
Okay.
And so they want them to float and then drift off. They don't want them to sink.
If they didn't hydrate, they would sink.
They would sink, yeah.
I see. So and what's the benefit of having them float?
It allows them to disperse, so then the larvae can disperse throughout. They do tend to stay in this area, depending on the currents, but they don't want to just drop down to the reef there. They'd get eaten by predators. They wouldn't survive. They need the water circulation. They need to be able to...
So the currents actually will take those eggs and they'll go around.
Yeah. Yep. So they can end up in Cuba. Some of them will end up... But some of them do, we've seen, based on... observations with what we call drifters, that are sort of floating objects that...
So a drifter is like a huge 10-foot sock that they'll hang, not really a sock, like a 10-foot net that's sort of in the shape of a sock. And on one end of it is a GPS at the top, and then the rest hangs down. It hangs down low enough that the current controls where it goes.
Yeah, the idea is that it's mimicking the behavior of a egg and a larvae when it's sort of in its planktonic phase.
So you'll put those out on the nights that they spawn, and those nets will follow the spawn because they're being carried by the same current.
Yeah.
And if you guys remember from the Changing Seas documentary that you've probably watched, and if you haven't watched it, I highly recommend you go and check it out. That this was something that we were researching for quite a while to see what happens to those eggs, and it seems that the Nassau, we don't know how, but somehow they're cueing in on something about the currents, that on the nights that they actually spawn, the currents are more likely to keep those eggs closer to shore.
Yeah.
And why is that important?
So then it'll help at least a subset of the population recruit back to this island. So it kind of keeps them close to land. Plus this island is sort of far from other land masses, so you don't want the larvae to drift off to Never Never Land. They need a
land.
reef, yeah.
Because what happens that the eggs are released and then they go off with the current, and how long are they floating around out there?
About 30 days, and then they'll hatch. Well, they'll hatch in 24 hours, but the larvae remain sort of planktonic for about 30 days or so before they can then recruit and then.
And planktonic means that they're literally floating around with the plankton, the microscopic animals and plants that are, okay.
Yeah.
And then after those 30 days, what happens?
Then we call them settle. They'll come in and settle at a reef, hopefully, or into like a bay area, and then those sort of juveniles settle in, and then they grow pretty fast. They'll begin to eat, like regular fish. But as they're larvae, they're just swimming around eating like plankton. They start to get the ability to swim, then eventually they get the ability to swim against current, and then they can actually kind of find their home. They'll sort of choose to come towards something. And there's studies, not so much with NASA grouper, but with other fish, that they can hear reefs, they can smell, they can sense where they need to go.
And I remember one year that we were listening to them. Do they make some sounds too?
The grouper?
Yeah.
Mm-hmm.
They actually make like kind of grunting vocalizations.
Yes. They have a lot of what we call courtship sounds that they make when they're spawning, and that gets the fish ready to go ultimately and calls them to that spawning site.
So they're really using multiple ways to communicate with each other. I mean,
Yeah.
they're talking, they're flashing their color, and even the way that they're moving is indicating
they
this is what we're doing.
nuzzle up to each other.
Right.
They get like nose to nose. Yeah, they're pretty cute.
So Allie is one of the researchers that goes out there every day, 8 o'clock in the morning, then again at around 1.
Yeah.
And then again at about, 5
Yeah.
or 5 or 6. So 3 dives a day out there. And I'm going to show you a little clip of what it looks like during the day when they're going out there looking at those NASA. It's just incredible. Look at all those fish.
Yeah, I almost prefer the day dives. 'Cause you can really,
You can really get a sense of
Yeah.
just the enormity of
see their personalities and just, get
that's
up close.
incredible. I hope you guys are all able to see that okay. All right. All right, so Allie, before I let you go, I'm not letting you go just yet. Thank you so much for being here.
Yeah, of course.
Can you tell us a little bit about how you got to be here? How did you get to become this marine scientist that you are today?
Sure. I actually ended up going to college for science, but I ended up getting a chemistry degree. But I had a natural resource management minor, and
What's natural resource management?
it's sort of like ecology, just general,
taking care of the
taking care of
environment.
the environment, yeah.
Okay.
Understanding how things interact. And so I was working in a pharmaceutical company for a while, and I just was bored after grad school, my bachelor's, and I volunteered at this nonprofit out in Borneo, Malaysia, and they taught you how to scuba dive, and then you taught you all of the fish and the corals. And so it was a 10-week project. I fell in love with diving. I fell in love with the marine environment. I fell in love with fish, and then I ended up staying out there for a year on another project
In Borneo.
Worked there. And
What were you studying there? What were you looking at?
Well, initially it was a project to sort of set up MPAs, so they were trying to find areas that had like the
so
health-
marine protected areas.
Yes.
Okay.
So trying to find areas that had the most healthy reefs or most fish life to protect, because
Yep.
there's a lot of destructive fishing practices out there.
Right.
But then it was an oil dispersant study, because I had the chemistry degree. It allowed me to kind of get this other project. And so it was just me and this other scientist, and we were going out and collecting samples of things, and we plumbed, tanks, and we exposed them to oil dispersants, because there's a lot of oil drilling in the area.
Oh.
So there was a project that was funded to see how badly dispersants in oil would affect marine
the
life. Yeah.
I see.
So that was great, and I loved
How
it.
long were you out there?
About a year.
Wow.
In this little tiny remote house, like up on the water. We had no electricity, no running water, rainwater for showers and drinking. We had a generator, for 2 hours
Apologies, you guys, we are back. Okay, so you were out there for a year. You realized you learned to
loved
dive.
it,
That
yeah.
you loved that, and then what? Where did you go after that?
So then I came back and started looking at grad schools, and I ended up, I wanted to get a degree to be able to get a position in marine science, and so I ended up getting my PhD at Rutgers University in New Jersey. And
Yeah.
so I was in New Jersey for a while doing more like mid-Atlantic stuff, but I loved the tropics, so I kept going back.
Apologies, you guys. One of the fun things about being on a field research project is that anything can and probably will go wrong at some point, and you have to be really flexible. And we've been struggling with our internet this year a lot. So apologies if we drop out again. Please just hang tight. We'll be right back. But okay, continue with.
So I got my degree, but in the meantime, I took other positions. I lived in Malaysia, in Hawaii for a little while, tagging manta rays, and then I went
Manta rays in Hawaii.
yeah.
Amazing.
And then I went to Turks and Caicos and did some lionfish work there, and then I actually came to the Cayman Islands and worked with Croy doing lionfish gut content analysis. And
What were you looking at? You were looking literally at what was in their
they were
stomachs,
eating,
what they were
yeah.
eating.
Yep. And then took a position in Little Cayman for 3 years after grad school and a postdoc. And so, yeah, when I was out here, I met the Grouper Moon Project team. And I had experience working with larvae and eggs, and I just kept asking them if I could help. I was
Yeah.
like, I'd like to be on this project.
So
yeah.
you kind of pursued it.
I pursued it, yeah.
That's
And
amazing.
then I ended up with Reef a couple years later, and so I've been with Reef for 5 years. Yeah.
That's wonderful. And
Yeah.
we have a new addition to the research team this year. Allie just had a baby. How long ago?
2.5 months.
2.5 months.
11 weeks.
So we've got a little 11-month-old a baby walking around or hanging out here with
Not
us.
walking yet.
11-week-old baby that's hanging out with us. That's incredible.
Yes.
I mean, that's something that I think is really unique about this project is that it really feels like a family,
Yeah.
and that
Yeah.
everyone pitches in and helps. And oftentimes there's kids of researchers that are here on the project. And
Yeah.
I think that's,
It's been great. Yeah.
that's wonderful.
Finley's loved it. She's loved being here. Yeah.
That's wonderful.
Yeah.
Well, thank you, Allie, so much for coming and joining
Thank
us
you
and,
for having
and
me.
sharing your story.
It was great.
Would you mind grabbing Janelle for
I
me?
will.
Okay.
I'll go get her.
So we're going to talk to one more scientist today who's actually a graduate student on the project.
If you want to do my history where how I got here, you could do that really quick.
Let's do that. So I'm going to bring Dr. Croy McCoy back on while we're waiting for Janelle. And he's just going to tell you, because I know that some of you guys are going to become our future scientists. And I want you to hear the different ways that you can find your way to be a scientist. So how did that work for you?
As I mentioned earlier, I was an avid diver from a young age. And
Right.
the curiosity got the better of me.
Yeah.
That's why I went off originally in 1991 to study marine biology at the University of Tampa.
Okay, so you went to Florida.
Yeah, I did my undergrad there, and then further, I worked for a while at the DOE after graduation in marine.
There in Tampa?
No, in
No,
Grand
here.
Cayman.
So you went there, came right back.
Yeah, and that, like I mentioned, that's where I started doing some of the Grouper Moon project
Right.
work. Mainly it was just looking at catch per unit effort.
What does that mean, catch per unit effort?
Basically, it gives you an idea of I guess you could say the density or the amount of fish, how much time
see.
you spent to catch one fish.
I see.
So-
I see.
And we were doing that at Easton and Grand Cayman. But in 2003, I went off to the UK. I did my master's at the University of Wales in Bangor. And
Wow.
I further did my PhD there.
Is there a
And-
relationship, because when I first started this project, I was staying at the DOE's apartment on Grand, and there was a number of graduate students that were also from that
Yeah.
program. Is there a connection there? Is that a
Yeah,
relationship?
When I started my PhD, the PhD is a lot of work, as anyone would tell you. And, there's a lot of these students that were up for distinction, so I needed very ambitious, smart people to
Yeah.
get all the work done
Yeah.
in the field. And so I started a relationship with the university then, taking on 4 grad students, because I had a lot of experience in the field, teaching them field methods,
Right.
supervising their their projects.
Okay.
And so that's where that came from. I still
I
do that
see.
up
I
until
see. Yeah.
today. I still supervise
Graduate students from there.
graduate students, not only from Bangor University, but St. Andrews,
Okay.
Exeter, and various different ones. So that has been very useful because at the moment I manage all the marine research for DOE or
That's
CI
right, you
Cayman
do.
government, and I get all these brilliant students that are like how everyone wants to get their feet wet
Yeah.
in the tropics.
Yeah,
and
exactly.
Studying whether it's fish populations, coral cover, lionfish, diets, densities, and distribution, and all these other factors.
Mm-hmm.
So I get a lot more work done. I never stop that relationship of having students doing a lot of the work and
Yeah.
teaching them at the same time every year.
Now,
In addition to the DOE staff that I supervise.
when you get your PhD, you have to focus in on something pretty specific. What was it
Yeah.
that you were studying for your PhD?
Well, I had a focus on marine protected areas. What works. In the beginning, I looked at every mile completely around the Cayman Islands, all 3 islands. I looked at the reef health, the fish population, all the metrics that would tell you if the system is healthy.
Yeah.
And it's like any other aspect of it. Always areas that stand out that are healthy, but you use those as seed sources for the unhealthy areas. So
So-
you have to capture them in that whole realm.
When you're looking for those healthy indicators, what is it that you're looking for? What are the indicators that this particular reef is healthy?
Well, we call it benthos, which is what's on the bottom.
Okay.
And you're looking at dead coral, the ratio to live coral, diversity, meaning how many different species there is there, and all the sponges and the fish populations. Different. We call them gills, where you have like parrotfish, you got the snappers and groupers,
Okay.
and stuff, and you put that whole picture together, and it gives you an idea of the health
Okay.
of that whole ecosystem.
Okay.
And that's what you're looking for, is those areas like that stand out, and at the same time try to protect those, because they are I call it money in the bank of seeding adjacent areas
For the future.
for the future. Yeah. And
Now, one thing that I think is important for everyone to understand, that seeing a lot of Nassau grouper, sort of top level or apex predators on a reef, is one of those important indicators of a healthy reef, right?
yeah, so are sharks too. I mean, it works as a big system, and when you, like we spoke about the Nassau grouper when we first started this project, it was down to 1,200 fish.
Right.
It's well north of 8,000 easily now, and there's lots of
amazing.
sharks, and the whole system is working.
Yeah.
And in nature we have top predators that keep that balance in the whole system, and when you see that live and working, it's really rewarding.
Yeah.
When you work on a project such as this. Even the brack went from less than 500 to 4,000 or 5,000 fish, and
That's incredible.
the jury's still out on Grand Cayman, but it's a very difficult area. It's exposed, it's deep, and a lot of strong currents and stuff. But we'll get there and trying to assess the population there. But we know we're getting recruitment because the juveniles are showing up in the reef.
So
That's
on
what's-
Grand, you're
yeah.
starting to see more juveniles, and that's telling you our population is growing.
Yeah, and it's working. Along with a lot of data that we talked about yesterday of the
Right.
size classes moving backwards, that shows you that the teenagers are coming in. So
Right. So explain that really quick. When we started, as we spoke earlier, we're measuring how big the fish are over and over again, and now you're seeing a bunch that are bigger, but then you're seeing another group that's growing in size. And what does that look
yeah,
like?
that's why you assess the size classes up to population. It gives you the distribution across there. But also, it took 10 years to actually see that size class move from the large size class to the smaller size class. Well, what that is telling us is that there's smaller fish that
Are joining the
are
aggregation.
joining the aggregation.
Right.
And that is a very positive sign.
Yeah.
Because nothing in nature or Mother Nature works overnight. Everything takes time. And it took us 10 plus years to
Yeah.
see this shift. that
Why do you
goes,
think it took so long?
It goes back, for one, the population, they're mass spawners. So not a whole lot survive.
Right.
from
And they
all
get
that.
one chance a year.
One chance a year. And like Ali said, the recruitment aspect of it, we are isolated oceanic islands, and it's only occasionally we think we have that pulse from external with a genetic mixin, but we're predominantly self-recruiting, and we
Self-recruiting meaning that we're pulling just
our
from
babies
fish
are
here.
coming back to here,
just here.
and you have to have a fairly large population to make that work,
I see.
and because you're dependent on yourself.
Right.
And I think that's what it really, when that started to get into motion, and we saw that happen, and that's when we started seeing this big shift and having that recruitment era of survivorship
Yeah.
in return back to our islands, because we know based on our data with that these islands feed each other with whether it's coral larvae. I did some genetic work in that, and that not only are
So
they,
corals actually spawn as well, you guys. I'm not sure if you know that,
Yeah,
but they do.
they have like a 2-week larval stage. I did some work in they have broadcasters and brooders, which brooders are next to each other, and the broadcasters in the water column for like 2 weeks.
Wow.
And even that work showed us that not only are corals related around the island, but they're related between the islands.
Right.
So it's all a big, I guess you'd call it a mix and bowl, in the sense that they work between each other, sharing larvae and genetics, and to make this whole system work.
That's amazing.
And with that, if you want to
Yeah.
Janelle on.
Right. Thank you so much. All right.
Bye, Arian.
So I'm going to introduce you guys to a graduate student who's going to be here in just one second. And then after we talk with Janelle, we're going to have time for questions. And remember, we've got this private chat, teachers on the right-hand side of the screen. If you have questions that you want to ask while we're talking, you can type them in there. But also, towards the end of Janelle's talk, we'll open it up for Q&A for anyone that's got questions. So with me today is Janelle Layton.
Hi.
Welcome, Janelle. Can you tell us a little bit about what it is you do on the project?
Yeah, so I am one of the graduate students in Dr. Scott Happel's lab, which I don't think you've met, but
Nope.
he's also one of the PIs for this project and has been here for
And PI is principal?
principal investigator.
So like one of the head scientists?
Yes.
Okay.
And so he's been working on this project for over 20 years now. And I just recently started I started grad school in 2020. So
Okay.
fairly new to the project compared to many of the other people you spoke with today. But with new people are new questions. And so a lot of my work looks at how climate change, or more so increasing temperatures, impacts early life history of Nassau grouper.
Okay, so you're looking at how climate change and specifically the increasing ocean temperature affects, you said, early life?
Yes.
So literally like the very beginnings of life.
Exactly. So the spawning aggregations you've been hearing about, a bunch of grouper will release eggs, and those eggs will get fertilized right there on site. And so we'll go out and actually collect full Ziploc bags of fertilized eggs, bring them back to the lab, and raise them for about a week here on location.
In little tanks that you
Yeah.
in your bedroom. Last year you should have seen the setup that Janelle had.
Yeah.
Of many different. Now, what was going on in those different tanks? What were you looking at?
So there were 2 sets of tanks that were a specific temperature. And
Okay.
so 2 sets were at 25 Celsius, another 2 at 27, another 2 at 29, and another 2 at 31.
Now, why those temperatures?
So 25 to 27 is current variability.
So currently, that's around where the temperature is, 25 to 27.
Exactly.
Okay.
So like 20 years ago when they started the project, it was closer to 25. Right now, it's closer to 27.
So the temperature has increased a couple of degrees.
Yes.
Just in the past 20 years.
Yes.
Okay.
And now...
And you expect that
we're-
to
yeah,
continue.
exactly.
So
we're
you're
expecting...
Go ahead.
We're expecting it to go up to 29 in the next, 100 years, and then 31 is also expected within the next 150.
Okay.
So
So tell us what you do. You're collecting the eggs, you're putting them in those different temperatures, and then what?
So we raise them for a week until starvation. So we're not feeding them, we're not doing anything. We're just seeing if they can make it to the full week.
Okay.
And if you're not eating, you should make it a full 7 days essentially. And so we
And does
see
that emulate kind of what would happen out there? Because they're not really. Are they eating when they are first being dispersed like that?
Not necessarily, because they're it takes a full like 24 hours for them to even
Hatch.
Yeah. And then they're also rising to the surface because a lot of this fertilization is happening at 80, 100 feet
Right.
below.
And then they're rising
yeah,
up.
and they're rising up. And then by 36 hours, or let me get my days right, 3 days in.
3 days in.
36 hours.
No, 72 hours.
72 hours. 3 days in, they will actually form functioning jaws. Is when they're actually able to start feeding themselves.
Okay.
So for those first 3 days, they're really just surviving off of their energy reserves, their yolk sacs, and their oil globules that they have already inside of their bodies. And then they'll start eating 3 days later.
Okay.
And that's when we're kind of expecting them to actually start consuming things.
Okay. So you're looking, so you watch them for a week, and what is it that you noticed happening in those different temperatures?
So at like 25 to 27, they're making it almost the full week. Most of them are. Mortality is happening, but not as high.
So mortality meaning deaths.
Death,
Some of
yes.
them are still are dying at 25 to 27, but not
Right,
many.
Not many.
Okay.
But then when you get higher, like 21, 29 and 31, you're seeing a lot more death, like much earlier on. Actually, around that time of day 2, day 3. So they're using all of their energy reserves so quickly that they can't actually feed themselves just yet, and all their energy reserves are gone because they don't have those functioning jaws.
So I'm going to pull up a picture so you guys can, we have got questions.
Oh, yeah, a lot of questions.
Great, you guys, I'm going to show you a picture of some of the eggs and what they look like in the different temperatures, and then we're going to get to all of your questions. So hold on one second. Okay, so what is it that we're looking at here, Janelle?
So we are looking at this is probably a day 1 egg at 4 different temperature treatments. So at 25, they're still eggs, not even hatched. But at
Right.
27, at that same timeline,
So kind of where they're at now,
Right.
like where we're at temperature-wise now.
exactly, they're hatched by day 1.
So so they're actually hatching sooner in the warmer
Right,
temperature.
in warmer temperatures.
Okay.
And then 29 looks a little bit similar to 27, but the yolk sac is slightly smaller, so they're absorbing a little bit more of their energy reserves.
So they're needing
here.
so in the higher temperatures they're using up more of their reserves
Right.
quickly.
Exactly.
And is that good or bad?
Not good. Like I said before, it takes 3 days for these fish to form functioning jaws. So those energy reserves they have inside need to last them those 3
I
days.
see. So if they use it up before they have functioning jaws, they're all
Smaller, and this is just day 1. So by day 3, a lot of that will be used up.
okay.
But this happens differently for each fish, each female that produces offspring. So some females produce these things called heat shock proteins, which help fish acclimate to changing
Higher
temperature,
temperatures.
changing environments, environmental variables, etc.
So what you're saying is some of those mamas out there are producing eggs that are actually better equipped to deal with higher temperatures and then some of them are not.
Right.
Okay.
So the moms that are doing that, they're passing on all these heat shock proteins that their babies can use to handle, how much they use their energy reserves with these high temperatures, etc. And others aren't. Some babies just don't have the heat shock proteins to support them, and they just have to go and burst through all of their energy before, they run out of food or whatever.
So as we see that temperature go up, we're going to see more of them die. But there is a bit of a silver
But
lining.
there's a silver lining. So, like I said, not all mothers are producing offspring with little heat shock proteins. And so ideally, we would want to keep the population as big as possible to keep passing on the genes of these mothers that have all of those like good genes, high quality genes, where they can survive things like climate change and climate changing environmental variables.
So the bigger the population, the better chances they have of survival and of those stronger genes being passed on and more of those surviving, and the population will start to become more of those fish.
Right, exactly.
Okay.
And that's how we're seeing more, population success and more survival of the species when the population is so big.
That's amazing.
Yeah.
How do you like working on this project?
I love it. It's a lot of work. but it's fun. Grad school in general, Corey was talking about it earlier, is a lot of work. Getting a PhD, a master's, whatever you're doing is a lot. But when you're really passionate about the project, when you're actually seeing conservation success over time, it's really exciting and it motivates you to want to keep going.
Yeah, and this project really is something that all Caymanians can be incredibly proud of. It's one of the most successful conservation projects in the Caribbean and really throughout the world. And that's all because of you guys taking care of your coral reef. So now we've got some questions. I'm going to run through them. So Miss Caroline's question, what is the ratio of males to females? Do you have any sense of that?
When spawning, it's always one female and then several males going around her. So that could be like 5, 6, 7 different males swimming around her. However, in the actual population, I'm not quite sure.
Okay. Would you mind going inside and seeing if anyone knows that? We'll get back to you on that one. Okay, how do you tell males from females? Now, that is not an easy thing to do typically throughout the year. But when they're spawning, it's easier.
It's much easier.
Why?
So females are hosting all of these eggs in their bodies.
Millions of them.
Yes, and so they have these big, pregnant, fat bodies, and they look huge compared to all of these smaller males swimming around her.
So when they're on the aggregation and we're swimming through them, you can actually tell the ones that are quite fat, those are the females. But if you were to go see them out on the reef during the rest of the year, you would have a really hard time being able to tell between male and female. You'd really probably have to capture them and look closely at their organs to be able to tell. Okay, so we just found out that the ratio of males to females is 50-50.
That's good to know.
So it's a pretty even balance of males and females. We have another question from Cayman International School. How do they change color? Is it hormonal or question mark? Now, I know that the grouper have the same sort of, I think they're called chromatophores that live inside their cells that octopuses have, and those chromatophores can change colors like that. And so they were born with that ability, and they can, I've dove out there many times with NASA just on their home reefs, and, they'll have that beautiful barred coloration on their sides, and if you hang out and watch them, if another one swims up, you'll see it change color to bicolor, like boom, like that. All of a sudden they change color, and they're telling that other fish, back off, you're in my territory, right? And so it's one of the unique and incredible things that NASA are able to do. It's just beautiful. Thank you for that question, Cayman International. Okay, now we have a question from Cayman Prep 4C. How far do groupers travel to get to the spawning location? Well, this again is a question that I've answered a few times before. I'm going to field that. It depends on the fish. Those older male fish, like Croy was talking about, they'll sometimes swim around the island multiple times before they end up on the aggregation. And that's not because they're looking for the aggregation. They're looking for other younger NASA and kind of coaxing them to go out to the aggregation. So they can often swim many miles before they end up out on the aggregation. How many fish do they reproduce each time? That's a good question.
Like how many eggs are they producing?
I think so.
Well, they're outputting millions and millions of eggs every time, but do all of them actually
survive?
Make it
No.
is another question.
Right.
So it's only about less than 1% of each egg actually gets fertilized and survives and makes it into the next population or
And
the next
recruits
generation.
back to shore. So.
Right.
So that's why it's important that we have such a huge population. It might sound like, one female can release millions of eggs. That's a ton. But when you have less than 1% surviving, you need to have that amount out there in order to have enough survive to come back and replenish the population and keep the population healthy and growing.
What do groupers eat?
What do groupers eat?
Everything.
They do. Grouper are not picky at all. If you notice, if you look closely at a grouper, they have large mouths, big lips, and they're part of the sea bass family, and those mouths can open really wide, and literally anything they can get their mouth on, they'll eat. So they can eat, other fish. They'll eat crabs. They'll eat anything they can get their mouth around. And they're those types of hunters that just sort of wait. They sit and they wait for something to come past, and then they'll whoosh, get it.
Yep.
Yeah.
They're top predators, so they're on the same level with sharks and other big things like that.
And those are so important. To have top predators on a reef tells us that the reef is healthy. And the reason that it's so important is that those top predators, they have an impact on all the populations below them. They will eat the sick and the weak out of those populations, and so that those fish don't end up reproducing. Only the strongest reproduce, and that helps. Hi, we're back. Okay, sorry about that. Okay, is timing based on okay, so when do they spawn? They spawn every year in the winter full moon,
Right.
right? So apologies, you guys. Life on the field science research project. Okay, so you're saying temperature is important, right?
Yes. Temperature is super important. In fact, they are spawning at the coldest time of year, January, February. And this is when ocean temperatures are quite low in that like 25, 27 degree range.
Right, and you saw, based on even your research, what happens to those eggs when the temperature is warmer. So they really do need that cold. That's what they're looking for, is the colder temperature for their eggs to survive.
Yes. Definitely.
Excellent question. Let me see.
Did we lose questions?
Yeah, we got them. Do all eggs survive each year? I think
No.
we've answered
Yeah,
that.
answered that.
Less than 1%, like much less than 1%, in fact. What conditions or areas do they need to spawn? Well, that's a great question.
That goes back to that temperature question. It needs to be the coldest time of year. So here in Cayman, they're spawning in January, but in other countries, like say more in like the southern hemisphere, the coldest time of year is not in the winter, it's actually in like our version of summer.
Right.
And so instead they would be spawning closer to like maybe July or August at that time. So temperature is a really important factor for them.
Absolutely. And another critical, so where they are here, where they're spawning is on the west tip of Little Cayman. And it turns out that this particular location is really critical for all kinds of species. It's not just the Nassau that go out there to spawn, but many marine species spawn out there. And we think that also has to do with the way the currents are working out there, that it's a really special place biologically for animals and marine life. And that's the same on the Brack as well. On the Brack, they spawn on the east end. And again, that's the spot where many of the marine species are doing their spawning. And so location is important, and temperature is incredibly important. How many types of grouper are there?
Oh, there are many.
40
Yes.
total around the world. 40 about 40 species. But
Here in Little, you would find Nassau, tiger, yellowfin, black grouper, maybe Goliath grouper. I'm not sure if they have.
I don't know if we've seen Goliath grouper. I think they have been here before.
Okay.
But yeah, so the tiger, the Nassau, the black, the yellowfin.
Yes.
Four species of Nassau, or 4 species of grouper that you'll find out there.
And actually on West End Little Cayman, they all spawn in that exact same spot. So first it'll be Nassau, and then a couple days later after Nassau finish, you'll see tiger starting to spawn.
Really?
And then a couple days after tiger, like a week after Nassau, you'll see yellowfin starting to spawn. We haven't actually seen black grouper spawn, but we can hear them. They're just a little bit too deep for us to dive to. But yes, they make these huge, like, boom, like they can hear, they make noises. Like
And you can actually
when
hear
they're
it.
moving. Yes.
That's amazing. Okay, so Miss Caroline's class question is, do they change color before spawning? And yes, they do. They totally change color. So, and they change color while they're out there. Often when they swim out to the aggregation, they're in their regular barred pattern, the coloration that you would see them on their home reef. You know, it's real beautiful kind of tiger stripes on the side. And then they get out there together, and the colors start to change immediately. Some of them will go all the way black. Some of them will put on their tuxedos, that black and white. Some of them will be in their regular coloration. But then as they get closer to the time of when they're going to spawn, all of them will have changed color. They'll be, you know, either bicolor or black. And that's what we've been seeing out there. When spawning, how many grouper are in their group?
I feel like it's a range.
It is a range.
There's always one female,
Uh-huh.
and then
All right. So, like Janelle said, it really depends. It can be anywhere from a few fish to, you know, maybe 10 or 15
Yeah.
following one female.
but that's specifically for Nassau.
Okay.
Not all groupers mass spawn like that. Some, like, I believe it's yellowfin, they'll do pair spawning instead, where it's just male.
Mm-hmm. So it's not a
female,
mass spawn like we're
yeah.
doing.
Yeah.
Just
so,
two of them.
Yep, it's just male, female swimming around each other, going up in the water column, and tigers also spawn slightly differently too. So it's only for Nassau's where they spawn like that.
So Nassau are really unique in the way that they spawn. Thank you for that question, Miss Caroline. Let's see, another one. Were groupers trained to eat lionfish? And that is a good question. There were some attempts to start training lionfish and sharks to eat the lionfish. And it was not all that successful, and ended up having some unintended consequences. You know, the fish started to look more to people, divers, for getting them fish instead of going and getting them on their own. So that was one of the strategies that they were attempting, but that hasn't really worked out. And then the last question from Miss Caroline's class is, how long are the eggs in mama for? Oh, I don't know the answer to that. Well,
Ask about that.
well, would you mind going inside and asking if anyone knows? We'll get back to that question. Now, we're just about done. If there's anyone of your classes that are out there that want to come up to your microphones and ask a question and be on the live stream, you're welcome to do that right now. And I'm just pulling up Miss Caroline's class because I wanted to say hi to you guys. Welcome. We're so glad you guys are here. You guys are awesome. I've loved all of your questions. They're the best.
Good question.
Okay, so now we have a question from Aryan, who is Dr. McCoy's son. Welcome, Aryan. I'm so glad you're here. The question is, how does the Nassau grouper protect itself from predators while spawning?
Oh, I can actually answer
You
that.
can answer that.
But I was going to ask Scott really quick.
Yes.
How long are eggs in their mothers for?
Well, I mean,
Scott, why don't you
Yeah.
come over here for a second? So I'm going to bring on Dr. Scott Happel, who is one of the lead researchers on the project and has been here for many years. Hi,
hey everybody.
Scott.
Hi Todd.
Hi.
This is
Janelle.
the PI I was talking about earlier. my
So this
PI.
is your teacher?
Yeah, exactly,
Yeah?
yes.
Okay.
Very good.
So go ahead with the question, which was,
How long are eggs?
how long are eggs in mama for?
So it's a good question. It's a little bit of a complicated question.
Okay.
But the eggs that are going to be spawned this year develop what we would say mature in about a month.
Okay.
So
Okay.
pretty quickly. So
Yeah.
they wait till the winter solstice when it gets really, really, because as dark as it's going to get, right?
Right.
And then the fish can tell it's starting to get lighter and lighter and lighter, and that's their cue to get ready to spawn. And then they wait for the full moon to get together to actually do that.
I see. Okay, now back to Aryan's question. How does the Nassau grouper protect itself from predators while spawning? And I think that's an excellent question. I'm sure many of you are wondering, well, you know, what happens out there when there's thousands, I mean, 8 to 10,000 fish, there's got to be, other predators showing up. What are you seeing? What's happening out there?
Definitely. I'm not sure if you've seen a spawning video already, but
I have, and in fact, we can pull one up for you guys in a second. Hey there, we're just pulling everyone into the screen. Welcome. So glad you're here. Okay, go ahead.
So if you've seen a spawning video, when watching it, you quickly see all of the sperm and eggs clouding the water. It reduces turbidity so quickly.
So when you go into the water before spawning, it's the normal clarity. You're seeing 80 to 100 feet. But then once they release their gametes, the visibility goes down to 0 essentially.
At times,
right?
yeah.
Okay.
Especially when there's so many fish there spawning at the same time.
So how do they protect themselves?
Well, you can barely see what's going on when you
So
get
you
there.
think that that's part of their defense is by releasing so much gametes out there, no, the predators can't see them to actually go in and get them.
Exactly.
And is that what you see?
I think that's part of it. And then there's the other part of the answer is how do they protect themselves? And the answer is partly not very well.
Right.
Right.
Because we've seen some NASA out there with big chunks taken out of them.
Right. And the thing to remember about that is when we see NASA down there with big chunks out of them, those are the ones that we see because they're still alive.
Right. But they're the ones we're not seeing are. There we go. Okay, we're back.
Yeah, so that Janelle was just talking about that cloud, that confusion is, of course, if you put a whole bunch of adult fish together in the same place, the probability that you're the one that gets eaten is also smaller. Hopefully
Okay.
it's your neighbor.
But we do see sharks out there circling the aggregation. And what I've noticed is in the videos that I've seen researchers share with us, that the sharks will try to dive in there during spawning, but often because they're moving around so much and those gametes are filling the air, that they just kind of miss.
They
They go
miss.
right through. They dart in there, and most of the time they don't get anything.
But every now and then,
And I'm going to actually just real quick again pull up a video of that so you guys can see what that spawning looks like because it's so beautiful. Actually, I like this one. That is amazing.
yeah.
And that was just taken last night, you guys.
Yeah. I didn't think I saw any sharks last night, but
No, not too many
just
sharks.
because I didn't see them doesn't mean they're not out there.
No, they're out there. We've seen many of them. In fact, we've seen some hammerheads out there too, haven't we?
Yeah, I've never had the privilege of seeing one, but others
Okay.
have.
Okay. Yeah, I haven't either, but I've heard about it,
Yeah.
and that makes me excited. We have a couple more questions. Oh, and we have another answer for how long do the females hold on to their eggs? They actually, what we're hearing is that the females will have them inside of them for almost a year before they release them, and then once they're released, they take about 24 hours to hatch,
Yep.
and then another 30 days before they're big enough to come back to shore. So Miss Caroline's class has the question, why do groupers like humans so much?
That's an excellent question.
That's a hard question.
Why do you think?
Well, I think here they like us a little bit more. And
In some places maybe they don't.
yeah, in some
Right.
places it may be different. And one reason they may like us a lot is because we're here every year. We're doing this project every year for the past 20 some years. And so
And every year we're not a threat. We're not going
We're
out there and
not.
capturing them, right?
right. So here we've already kind of established a relationship with a lot of the specifically Nassau group we're out here. But it may not be the same in like the Pacific or other places.
Yeah.
Do you think that do you think divers also have an impact on how Nassau see people? Like just the fact, somewhere, like the Cayman Islands where you have a pretty large diving industry and people are in the water a lot, the Nassau become, I don't know, it's more normal for them
Yeah.
to see people.
Yeah, we might say they become what we could say acclimated to
Right.
us, right? They
Right.
get used to us in that
Okay.
way. Yeah, because of course a lot of the fish that we see out at the spawning aggregation are coming from, say, Bloody Bay,
Yeah.
where there's divers in the water all the time.
Exactly.
right? And then the other thing I think a little bit is that they might think of us as a way for them to get a meal, right? 'Cause
Right.
if we're in the water, maybe we're distracting something that they want to eat,
Exactly.
which makes it easier for them to eat us, and they associate being able to get food with us,
So that could be also part of it.
right? And,
Wonderful.
right. I tend to like the people that feed me.
I do too. I bet you guys do as well. Is there anyone else that's got a question? We are just out of time. We're going to wrap up right now. At Cayman International School, the question is, do females release all their eggs at the same time? Good question.
Yes.
Yeah, mostly,
them.
right? And so we're seeing this year 4 different nights of spawning, and likely, so for all the same, when we say at the same time in the same aggregation period, yes. In the same spawning rush itself, no.
I see.
Right.
So
So-
they're releasing multiple times.
Yeah.
Correct.
Great
And
question.
they can come back next year too.
Right.
And do it all over again.
Right, and they can come back every year, and until they die. They're reproductively active all the way through their life. Once they become mature enough, which is at about 7
7 years?
years of age. All right. Well, that's all the time we have for today. Oh, Arian's got one more question. We've always got time for one more question. Why did the Grouper Moon project not take off till the rediscovery of Nassau Grouper in the west end of Cayman?
That's a really good question for the Department of Environment, but I'll try to answer that, I think. And what
Hillary,
I would
could you
say
grab a
is
DOE
that
person if
I
you're
think
in there?
that a lot of folks felt that all hope was lost, that there wasn't any point in
Right.
trying to do something like this. And then there was this really amazing discovery here on Little Cayman, and people just sort of grabbed a hold of that and said, hey, we really can do something. Let's do it right. Let's do it this way. Let's get everybody together. Let's understand what's going on, and we can build from there. And here we are 20 years later, and like I'm sure has already been talked about with the students, one of the most amazing marine fish conservation projects in the entire Caribbean is happening right here, 4 miles from where I'm sitting right now.
Yeah. So thank you so much for that question. Now, that's all the time we've got for today. I want to thank all of you guys for showing up today, and I have a few thank yous that I want to send out to the people that are helping make this project happen, including Peter Hillenbrand here on Little Cayman and Southern Cross Club, the Little Cayman Beach Resort, Reef Divers, and Jason Bellport. Thank you for all of your support. Berkeley White at Backscatter, and Marissa with Pegasus Thrusters. We couldn't do it without all of your guys' support. And you, the youth, we need you guys to understand and learn this stuff, and then to carry it on into the future and become the next generation of scientists that are going to continue this work and keep making keep protecting this important resource that you have on Little Cayman. So that's it for today. Bye, you guys. Thank you all so much for being here.
It's great to see you all.
Don't forget to show up tomorrow, where we'll be diving on Bloody Bay Wall. We'll go underwater. We're going to take you down and see everything that's down there. So join us tomorrow, 10:30. We'll see you then. Take care, you guys.